Let's set the scene. Picture this. It's a blistering 45 degrees in the middle of May in India. The asphalt outside literally melting. The air itself feels like an oven. Now, if you stop someone on the street in this intense heat and ask them, hey, what day do you think a solar panel produces the absolute most electricity? They would intuitively point right at the blazing sun and say, today, right? I mean, the hottest was brutal day of the year just makes sense. But what if I told you they would be completely wrong? Because, okay, here is the secret that almost nobody talks about. Solar panels do not run on heat. They run on light. So on that incredibly scorching May afternoon where you're sweating just standing still, your panels might actually be producing significantly less power than they did on a crisp, pleasantly freezing morning back in February. I know, right? No way. It totally shatters everything we instinctively assume about how these machines work. Welcome to The Explainer. Today, we are unpacking the heat myth. And honestly, this is arguably the single biggest solar misconception that people still believe today. But understanding the actual science here, it isn't just some fun piece of trivia. It is an absolute game changer. It's going to completely reshape your expectations, how you view your entire investment, and even alter how you go about installing these systems on your roof. To really see this in action, let's look at a quick case study. Let's talk about Rajesh. Rajesh is a school teacher living in Nagpur, which, if you know it, is consistently one of the hottest cities in India. When Rajesh installed rooftop solar, he was thrilled. He was actually bragging to his neighbors, saying, Nagpur gets brutal sun. My panels are going to be working overtime. He was so confident he'd see absolute maximum power generation when the thermometer hit a crushing 46 degrees Celsius. But then June hits. The temperatures cross that massive 46-degree mark. Rajesh eagerly pulls out his phone, opens his solar monitoring app to check his record-breaking numbers, and wait a minute. Something is really strange. His generation for this blistering June was inexplicably lower than his generation in March, a month that wasn't even close to being that hot. He was absolutely stunned. Was the equipment broken? Did the installer scam him? He spent 2 incredibly anxious weeks sweating over what he thought was a massive financial mistake until an engineer finally sat him down and explained the reality that most solar buyers literally never hear. So let's break down the science of what was actually happening up on Rajesh's roof. Think of a solar panel kind of like a cricket batsman. The sunlight hitting the panel, those are the deliveries. They're these billions of tiny packets of light called photons, and they are essentially being bowled at your roof every single second. When a photon strikes the panel, it knocks an electron loose inside the silicon. Bam! Exactly like a batsman, making perfect connection with the ball. Millions of these tiny hits all flowing together, that becomes your electric current. That is the fundamental magic of solar power. Light goes in, electricity comes out. But here's the twist. This is where the heat actually messes things up. Imagine forcing that exact same batsman to play an intense match inside a steaming hot sauna. Inside every single panel, those electrons we just talked about need to move in a smooth, orderly flow to generate power efficiently. But when the silicon gets extremely hot, its atoms start to vibrate chaotically. Suddenly, those moving electrons face intense resistance. It's exactly like our batsman trying to sprint between the wickets through thick, heavy, suffocating air. The panel is still working, for sure, but its efficiency is quietly taking a huge hit. Which brings us to a really crucial engineering term. The temperature coefficient. It sounds a bit complex, but it's basically just the fraction of output a panel loses for every single degree it climbs above 25 degrees Celsius, because 25 degrees is the baseline testing standard. But think about it. On a 45-degree afternoon, the actual physical surface of that dark panel baking on your roof, that can easily cross 60 or even 70 degrees Celsius. And that is exactly what happened to Rajesh. His panels weren't broken. He wasn't cheated. They were just, well, way too hot. So here's the ultimate truth to our mystery. The absolute ideal day for solar is not the hottest day. It's the brightest, coolest day. What you really want are clear skies, super strong sunlight, and maybe a nice, gentle, cool breeze blowing behind the panels to keep them chilled. This actually explains a huge historical puzzle, by the way. It's exactly why colder, cloudier countries like Germany were able to pioneer the solar revolution. And it shows us India's true advantage. It's not the brutal heat. It's the fact that most regions get nearly 300 days of abundant, bright sunlight. Light is the fuel. Heat is just a passenger. And honestly, a pretty unwelcome one. Knowing all of this is absolutely crucial for your wallet. To protect your investment, we've got a simple 3-step playbook for you. Step 1, ensure proper ventilation air gaps. If your panels are mounted with a proper gap underneath, they stay cooler and perform vastly better. A rushed install that's pressed totally flat against a boiling roof, that is just a giant heat trap. Step 2. Keep realistic summer expectations. If your numbers dip slightly during peak summer, it's just physics, guys, not fraud. Knowing this saves you so much unnecessary panic. And step 3, always check the temperature coefficient datasheet. Don't just look at the wattage. Two panels with the exact same rating can behave totally differently on a hot roof depending on how they handle heat. Now, obviously, while temperature is a massive factor, your actual generation and your financial savings depend on a whole ecosystem of variables. We're talking your geographic location, the exact direction your roof faces, shading from nearby trees or buildings, your daily electricity usage, local discom rules, and of course, government policies. All of this, paired with installation quality, means the final numbers vary wildly from house to house. So definitely make sure you verify current subsidy schemes directly on official government portals and consult qualified pros before dropping your cash. Honestly, navigating this whole complex market can feel totally overwhelming. It's a lot, which is exactly why platforms like Solar Mart exist. It is pretty much the ultimate place to explore verified vendor profiles. At Solar Mart, the core belief is that the best solar investment begins with the right information. You can go on there, compare trusted solar companies, figure out who actually understands things like ventilation gaps and temperature coefficients, and essentially become a highly informed buyer way before you ever choose an installer. Because at the end of the day, the most powerful thing sitting on your roof isn't the solar panel itself, it's your knowledge. An informed buyer asks questions that an uninformed buyer doesn't even know exist. So I'm super curious. What solar fact have you always believed that you're now thinking might just be a myth? Drop your thoughts in the comments below. Let's uncover the truth together. Keep asking the right questions. Be sure to visit Solar Mart to find truly trusted options, and until next time, stay curious.